Mars, often referred to as the Red Planet, has captivated the imagination of scientists, astronomers, and the general public for centuries. In recent decades, significant advancements in space exploration technology have allowed for a more in-depth investigation of Mars, progressing from robotic missions to the ambitious goal of potential human colonization. Here is an overview of key milestones and developments in the exploration of Mars, focusing on robotic rovers and the prospects for human settlement. The Viking program, initiated by NASA, marked a groundbreaking era in Mars exploration with the successful launch of two spacecraft, Viking 1 and Viking 2, in 1975. These missions were designed to conduct comprehensive scientific investigations on the Martian surface and in orbit. Each Viking spacecraft consisted of an orbiter and a lander, equipped with an array of instruments to study the planet's atmosphere, weather patterns, and surface composition. The Viking landers successfully touched down on the Martian surface in 1976, representing the first successful landings on Mars. The primary goal of the Viking landers was to search for signs of microbial life, and they carried out 3 biology experiments designed to detect metabolic activities associated with living organisms. Despite inconclusive results, the experiments provided valuable data on the Martian soil's composition and the presence of oxidants that could potentially hinder the existence of life. The Viking orbiters, equipped with high-resolution cameras and other scientific instruments, played a crucial role in mapping the Martian surface and studying its geological features. They also contributed to our understanding of the planet's polar ice caps and seasonal changes. The Viking program laid the foundation for subsequent Mars missions, establishing a framework for the scientific exploration of the Red Planet and inspiring future robotic and human exploration endeavors. In 1997, NASA's Pathfinder mission represented a significant leap in Mars exploration by introducing both an innovative landing system and a groundbreaking mobile robotic rover, the Sojourner. The Pathfinder spacecraft, carrying the Sojourner rover, successfully landed on the Martian surface in Ares Vallis on July 4, 1997, becoming the first mission to use airbags for a safe descent onto another planet. The Pathfinder mission was designed as a technology demonstrator, testing new landing techniques and enabling surface operations with a compact rover. Sojourner's successful exploration of the Martian terrain marked a significant milestone, covering a distance of about 100 meters during its 83-day operational period, far surpassing its originally planned mission duration of 7 days. The rover's observations provided crucial insights into the geological characteristics of Mars, including the composition and texture of rocks, and contributed to our understanding of the planet's ancient history and climate. The Pathfinder mission not only demonstrated the feasibility of robotic exploration on Mars, but also paved the way for future rover missions by showcasing the importance of mobility in conducting detailed surface analyses. Building on the success of the Pathfinder mission, NASA launched the Mars Exploration Rover (MER) mission in 2003, deploying twin rovers, Spirit and Opportunity, to explore different regions of the Martian surface. These rovers were equipped with a suite of advanced instruments designed to analyze the geological composition, mineralogy, and morphology of Martian rocks and soil, with the primary goal of understanding the planet's past water-related processes. Spirit landed in Gusev Crater on January 4, 2004, while Opportunity touched down on the opposite side of Mars in Meridiani Planum on January 25, 2004. Each rover had a planned mission duration of 90 Martian days, sols, but both significantly exceeded their expected lifetimes, operating for several years. Spirit, despite facing challenges like a wheel malfunction, explored the rocky landscape of Gusev Crater for over 6 years. It made a groundbreaking discovery of evidence suggesting that the site had once been a lakebed, providing crucial insights into Mars' watery past. Spirit also analyzed the composition of Martian rocks and soil, revealing the presence of minerals indicative of past hydrothermal activity. Opportunity, meanwhile, explored the plains of Meridiani Planum for over 15 years. It made an iconic discovery when it identified hematite-rich spherules, often referred to as blueberries, suggesting the past presence of liquid water. Opportunity's longevity allowed it to traverse large distances, studying diverse geological features and contributing to our understanding of the planet's dynamic history. The Spirit and Opportunity rovers significantly advanced our knowledge of Mars's geological evolution, with their findings supporting the hypothesis that liquid water played a crucial role in shaping the Martian landscape. Curiosity, also known as the Mars Science Laboratory, MSL, represents a pinnacle in Martian rover technology and scientific instrumentation. Launched on November 26, 2011, and landing on Mars on August 6, 2012, Curiosity was designed for a primary mission duration of 1 Martian year, equivalent to approximately 687 Earth days. However, due to its robust design and performance, Curiosity has significantly exceeded its initial mission duration, providing invaluable data for over 9 years. As of the last knowledge update in January 2022, Curiosity was tasked with exploring Gale Crater, a 154-kilometer-wide impact crater with a layered mound at its center called Mount Sharp. The rover's primary objective was to investigate the history of water on Mars and assess the past habitability of the Martian environment. Equipped with a suite of advanced scientific instruments, Curiosity aimed to detect and analyze organic compounds, the building blocks of life within the Martian soil and rocks. Studying the modern climate and the processes that shaped the Martian surface, including wind and erosion, was another critical aspect of Curiosity's mission. Curiosity's exploration revealed evidence of an ancient lake in Gale Crater, suggesting a potentially habitable environment in Mars's distant past. The detection of organic molecules in Martian rocks and soil hinted at the possibility of ancient organic compounds, although their origin is still under investigation. Curiosity detected seasonal variations in methane levels in the Martian atmosphere, raising questions about the potential sources of this gas. The discovery of clay minerals in the region known as Glen Torridon indicated a history of water alteration in the Martian past. Curiosity's landing system involved a complex and innovative sky crane maneuver, where the rover was lowered to the surface on a tether, providing a controlled descent and precise touchdown. Curiosity featured 6 wheels with individual drive motors, enabling greater mobility and the ability to traverse challenging terrain, including sand dunes and rocky surfaces. The rover employed artificial intelligence algorithms for autonomous navigation and decision-making, allowing it to avoid obstacles and select scientifically interesting targets. Perseverance, the latest addition to NASA's Martian exploration fleet, represents the culmination of technological advancements, scientific ambition, and the pursuit of potential extraterrestrial life. Launched on July 30, 2020, and landing on Mars on February 18, 2021, in the Jezero crater, Perseverance is part of the Mars 2020 mission, aiming to build on the successes of its predecessor, Curiosity, and address key scientific questions related to Mars geology, climate, and the possibility of past life. Perseverance is equipped with advanced instruments, including a sample caching system, to collect and store Martian rock and soil samples that may contain signs of past microbial life. The rover's landing site, Jezero Crater, is believed to have housed a lake and a river delta in the distant past. Perseverance is tasked with exploring this region to understand its geological history and potential habitability. Perseverance carries the Ingenuity helicopter, a technology demonstration designed to test powered flight in the thin Martian atmosphere, providing insights into the feasibility of aerial exploration on Mars. Perseverance carries the Mars Oxygen In Situ Resource Utilization Experiment, MOXIE instrument, which aims to demonstrate the extraction of oxygen from the Martian carbon dioxide atmosphere, a crucial step for future human missions. Perseverance successfully recorded the first audio sounds on Mars, capturing the wind and mechanical sounds of the rover itself. The Mars helicopter Ingenuity conducted a series of successful flights, achieving the first powered, controlled flight on another planet and providing aerial views of the Martian surface. Perseverance has successfully drilled and collected rock samples, which will be cached for potential return to Earth by future missions. Perseverance utilized an innovative technology called terrain relative navigation, allowing it to autonomously adjust its descent path during entry, descent, and landing to avoid hazardous terrain. Perseverance employs state-of-the-art imaging technologies, including artificial intelligence for autonomous navigation, allowing the rover to identify and avoid obstacles in real time. The rover's sampling and caching system is designed with higher precision, enabling it to collect and store core samples in airtight containers for potential return to Earth. The prospect of human exploration and potential colonization of Mars represents a bold and visionary venture that has captured the imagination of scientists, space agencies, and private companies around the world. This phase of Martian exploration goes beyond robotic missions and aims to establish a sustained human presence on the red planet. Several ambitious projects and initiatives are shaping the future of human activities on Mars. The vision for human exploration of Mars involves sending astronauts to the Martian surface for extended missions, ranging from scientific research and resource utilization to the establishment of habitats for long-term stays. Key space agencies and private entities, such as NASA, SpaceX, and international collaborations, have outlined plans for crewed missions to Mars. NASA's Artemis program, originally focused on lunar exploration, also envisions using the Moon as a stepping stone for future crewed missions to Mars. This approach involves testing technologies, habitats, and life support systems in the lunar environment before embarking on the longer journey to Mars. Private companies, notably SpaceX, have put forward ambitious plans for crewed missions to Mars using the Starship spacecraft. Designed to be a fully reusable spacecraft capable of carrying large numbers of passengers, Starship aims to facilitate the transportation of humans and cargo between Earth and Mars. Establishing a human presence on Mars requires robust life support systems to ensure the survival and well-being of astronauts in the harsh Martian environment. The challenges include providing breathable air, sufficient water, and a reliable source of food. Developing methods for generating oxygen on Mars, either through in-situ resource utilization, ISRU, or other technologies, is crucial for sustaining human life. Efficient extraction and utilization of water resources on Mars are essential for hydration and supporting various life support systems. Closed-loop systems for recycling waste products, including carbon dioxide and organic matter, contribute to the sustainability of life support systems. While terraforming Mars, altering its atmosphere and surface to make it more Earth-like, is a concept that remains in the realm of speculative and theoretical discussions, it has been considered a potential long-term goal. However, the challenges and ethical considerations associated with planetary engineering are significant. Some proposed terraforming concepts include introducing greenhouse gases into the Martian atmosphere to trap heat and initiate a warming effect, potentially triggering processes that could lead to the release of frozen water and the creation of a thicker atmosphere. Deploying large magnetic shields to protect Mars from solar wind and radiation, with the goal of preventing atmospheric erosion. In the absence of complete terraforming, constructing enclosed habitats on Mars with controlled environments could provide a more immediate and feasible option for human colonization. The prospect of human colonization raises important ethical and environmental questions. Preventing contamination of Mars with Earth organisms and vice versa to preserve the scientific integrity of Mars and prevent potential harm to indigenous Martian life, if it exists. Ensuring that human activities on Mars are sustainable and do not deplete Martian resources beyond their natural replenishment rates. Collaborative efforts involving multiple nations and private entities are crucial to addressing the complex challenges associated with human exploration and colonization. Ongoing and planned robotic missions, such as NASA's Artemis program, will continue to pave the way for future crewed missions to Mars. These precursor missions aim to test technologies, gather essential data, and mitigate the risks associated with human exploration. Continuous advancements in propulsion systems, life support technologies, habitat construction, and resource utilization will be instrumental in making human exploration and colonization of Mars a reality. Collaborative efforts involving space agencies, private companies, and international partnerships will play a key role in pooling resources, expertise, and funding to address the multifaceted challenges associated with Mars exploration and colonization. As humanity stands on the cusp of a new era of space exploration, the endeavors towards human exploration and the potential colonization of Mars represent an unparalleled and exciting chapter in the history of space exploration. While significant challenges lie ahead, the collective efforts of the global space community aim to turn this vision into a tangible reality, with Mars serving as a potential stepping stone for humanity's expansion into the broader cosmos. Thank you for joining Time Pilgrimage on this adventure, and as always, don't forget to like, comment, and subscribe to our channel for more captivating time and space-related content.